Hello, everyone. This is Edwin from Red Hat APAC Solution Technology Practice Team. Let me tell you two things about in this session. The first is the value of OpenShift in terms of how OpenShift had to operate container in the enterprise and how OpenShift had to adopt container for the enterprise application development. And the second is ARO 4.3 is running based on OpenShift 4.3. So I would like to share new features which is helping to empower development productivity in terms of OpenShift development console tools, microservices development frameworks, and built-in CI/CD tools. Let's talk about Kubernetes implementation in the right way for the enterprise. While it actually is not that hard to download and install Kubernetes, getting it really ready for production to run business critical applications for an enterprise takes a lot more effort. There are a number of things that need to be pieced together, tested and hardening for operations in terms of security, networking, and storage and enterprise app operation. For instance, just take identity management with Kubernetes. You will be providing access to critical internal systems to employees, partners, and customers. You need to adhere to the security rules established in the company. The way to do that is to write an integration between Kubernetes and your company's approved LDAP. That requires knowledge of DAX, the open source identity system, Kubernetes and integration system to LDAP. Similarly, you will need to hook up Prometheus, open source monitoring and alert system, or hook up another monitoring system so you can get full visibility into your Kubernetes operations in testing and production. This is why we are saying Kubernetes don't like this hard. So we grouped three categories, issues and challenges that companies face when they adopt container platform like Kubernetes. We hear about that. The first is container security and compliance. And the second is data management, like install, upgrade, and etc. And third is app development and management. Let me go through what is the value of that OpenShift provides in each of these categories. We take container security very seriously and take a holistic approach to deliver what we call the trusted enterprise Kubernetes platform. Containers are Linux, and so is Kubernetes, because we also provide LEL, which is trusted by 1,000s of enterprise worldwide. We can deliver a secure platform across the stack and stand behind it with long-term support. We recognize that keeping up with the frequent upstream release can be challenging, and we are investing in automated capability like the operator framework and over-the-air updates to make it easier to keep up to date with the latest innovation coming out of the community. While customers have a demand on learn application in many clouds, they also want to reduce the amount of operational complexity that comes from multi-cloud strategy. OpenShift enables customers to have a consistent development and operational experience across any combination of cloud, public or private or bare metal. It's all about the development. It's all about the developers, and we are investing in automation capability in OpenShift, CI/CD pipeline, A/B testing, and etc. Developer tools like Code-Red Workspace and Cloud Native Framework include Spring, Serverless, and Windows Container to inspire developers to create the best code. No matter what application you are building, chances are you can improve developer productivity with OpenShift. So we call the OpenShift Container Platform is a smarter Kubernetes platform. Kubernetes itself is not the end game. Our objective of adopting container is that deliver application with modern development practice like DevOps and microservices architecture to deliver business value to the market more faster and flexible way. To enable this OpenShift, with this foundation of Trust Enterprise Kubernetes platform, we add productive enhancement to deliver an application platform with all the components you need that are fully integrated to build, deploy, and management containerized applications. Kubernetes updates, security patches, and component updates can be deployed with a single click. Based on Core OS, OpenShift can actually update the underlying operating system and scale at node level, which is particularly useful when you deploy OpenShift on cloud infrastructure because the entire cluster can scale up and down based on your application needs. As mentioned before, lots of new features comes with ARO 4.3, which are a part of OpenShift 4.3. From the ARO 4.3, OpenShift is running with Kubernetes 1.16 on the Core OS, Red Hat Enterprise Linux Core OS. Core OS is an immutable container-optimized Linux OS host that is delivered and installed as a component of the OpenShift. And also, ARO 4.3 includes service mesh and serverless for modernized application development, like MSA and event-driven function-based application. There are also a couple of tools for developer in ARO 4.3, audio and other development tools. Let's go through features one by one in the next slides. I will talk about new features which are related to develop and operate application on the OpenShift platform, and how OpenShift have to accelerate developer productivity. Let's talk about OpenShift 4 enables a cloud experience everywhere by automating data management. OpenShift can learn from bare metal to public cloud and operate it as the managed service like ARO. But OpenShift provides the necessary tooling and process automation to enable teams to operation Kubernetes efficiently, and also provides consistent environment to the developers. OpenShift cluster operators from OpenShift 4 is making available cluster automation and manage the lifecycle of the cluster component throughout the platform. And cluster operator makes upgrading OpenShift clusters in production a risk-free and repeatable task, and as simple as updating an application on your iPhone. Let me tell you about Operator Framework. The Operator Framework is a set of tools that helps you build and learn operators on a Kubernetes cluster, including an SDK to get you up and running quickly. Not only used on building cluster automation, this operator component is also using to manage application's whole lifecycle automation. Install and deploy app to the cluster and monitoring and managing through the operator framework. So you can simply say operate codify of operational knowledge and workflow to automate lifecycle management of containerized applications with Kubernetes. So how do you get these operators in the OpenShift? The OperatorHub was launched by Red Hat and other partners, Microsoft and AWS and Google. It provides a single place on the internet for developers to publish operators and for customers to find and consume created operators. These operators meet certain quality standards, so you can have the confidence they deliver what they promise. You can deploy these operators on any Kubernetes distribution, not just the OpenShift. But we've also integrated the OperatorHub into OpenShift, where you can also find fully certified operators from our partners and us. That meets a very high bars of quality standards, like Elasticsearch logging, EFK. Inside of OpenShift, admin have full control over which operators are installed across the cluster and gain tools for upgrading them from a center point. Engineers interact with operators in a self-service manner, just like any other Kubernetes object. Here you can see a developer's view of all operator capabilities exposed to them, which self-service access to manage them. Let me talk about OpenShift 4.3 features and ARO 4.3 features for developers. ARO 4.3 provides familiar OpenShift experience. You can use the tools and command you can already know and use in the OpenShift cluster. OpenShift enables developer productivity. No matter what architecture you choose for your applications, what program language the developers find most useful, and what services you want to use as building block, OpenShift provides a single and consistent development model across the build, test, deploy, monitor, and review lifecycle of the application. First is a self-service infrastructure. Developer can provision what they need on demand and skip waiting for hours, days, and something weeks for infrastructure resource. They can they are provisioning from the OpenShift self-service provisioning service. Second is consistent environment. OpenShift makes sure the environment provisioned for developers and across the lifecycle of the application is consistent from the operating system to libraries, runtime versions, and even the application runtime in use in order to remove the risk originated from inconsistent environments. And automated build and deployment. OpenShift gives a choice to developer to build their containerized application themselves or to have the platform build containers from the application source code or binary. The platform then automated deployment of these applications across the infrastructure based on the characteristic that the teams has defined for the app, such as how much resources should get allocated and where on the infrastructure they should get deployed to be compliant with third-party license. Continuous delivery pipeline. OpenShift provides out-of-the-box support for the CI/CD pipeline, so that development team can automate every step of the application delivery process and make sure it's executed on every changes that is made to the code or configuration of the application. And configuration management and sensitive data management is built in the platform to ensure consistent environment agnostic application configuration is provided to the application, no matter what technology is used to build the application and which environment it is deployed. And also, application and logs and metrics is provided and integrated OpenShift monitoring and log management system, which is Prometheus in the OpenShift 4.3 and Elastic search-based EFK stack to aggregate the logging of the application. And also OpenShift provides streamlined developer console. A developer-centric perspective offers a simplified view of Kubernetes concepts, so developers can focus on what really matters. The console allows developers to import their source code from Git or GitHub, view and manage app configuration and workload details, and deploy their applications all through this dedicated interface. Improved topology view in the ARO 4.3, we added a lot of contextual actions plus allow you to quickly toggle to the list view to give access to developers all relevant info for their apps. We have made it simple to group and bind apps and services together from the topology view. This is really about making the developers as productive as possible without having to get into Kubernetes underbelly. The next one is enable development to enable developer productivity. We provide a couple of development tools for the developer. In terms of developer tools, Code-Ready Workspaces provides an Eclipse chair-based developer IDE that is tightly integrated with OpenShift. Code-Ready Workspace provides support for development team to build application together. But even if you are using Visual Studio Code, IntelliJ, or other IDE, OpenShift plugins allow you to use your existing tools, deploy your apps on OpenShift. And for command line users, ODO gives you a very powerful CLI to deploy applications on the command line. Code-Ready Workspace. There are some key advantages to use Code-Ready Workspace with OpenShift in terms of accelerate onboarding, pre-configured and shareable dev workspace with all tools pre-installed workspace, including DevOps integrations, can provide to the developer. In terms of consistent workspaces, identical workspace to remove works on my machine and enhance team collaboration. In terms of protect source code, no code on the hard to secure developer and personal laptops. If you secure your source code repository with like GitHub secure functions, you can mitigate source code security risk. OpenShift ODO is a fast, iterative, and straightforward CI tool for developers who write, build, and deploy applications on the OpenShift. OpenShift supports a very broad range of application types of framework. Service mesh and serverless are exciting technologies that makes it easier to build and learn microservice architectures, and we support both in OpenShift 4 and ARO 4.3. The service mesh is a layer that manages the communication between the individual services that works together as an application. The routing rules and communication security can be managed by service mesh instead of being hard-coded into the application or manually defined. The OpenShift service mesh is based on Istio, but is also packaged with Jaeger and Kiali to improve observability of the service mesh. This picture demonstrates traffic management of the service mesh for the A/B testing. Like this, you can easily control traffic at the application level to leverage service mesh traffic management. And Jaeger, which is packed with OpenShift service mesh, can visualize the service execution times across the application. This helps identifying potential latency issues in each services. Kiali works to visualize the service mesh topology, identify which services are part of the service mesh and how they are connected. And Kiali also enabled to understand the topology and health of the service mesh. The next is OpenShift Serverless. We have backed serverless capability into the platform with OpenShift Serverless, enabling almost any containerized application to run serverless. That means you can choose any program language of choice and enable auto-scaling behavior, scaling up to meet demands and down even to 0. Beyond auto-scaling of the scaling for the request, you can trigger those serverless containers from a variety of event sources and receive events such as Kafka message and file upload to the storage, timers for recurring jobs, like that. OpenShift Serverless is based on this open source project Knative, one of the fastest growing serverless projects in the market. This ensures that you don't suffer with lock-in concerns and can still get the innovation from a growing open source community. So the last feature of this session is a cloud-native CI/CD with OpenShift Pipeline. Cloud-native CI/CD is based on Tecton pipelines. This can learn serverless and containers build images with Kubernetes tools, S2I, Builder, and etc. Pipeline is able to be portable to any Kubernetes distribution. This is available in the OperatorHub. Tecton pipelines VS Code extension enable create, trigger, and manage Tecton pipelines on OpenShift and Kubernetes from Visual Studio Code. And also, you can still use Jenkins container in the OpenShift cluster. Compared to OpenShift 3, Jenkins server runs on JDK 8 and 11. And there are two types of Jenkins agents, JDK 11 and Node.js 10 is providing. You can install through OperatorHub IO, and you can still use Jenkins for writing CI pipeline in the OpenShift. So this is my end of my presentation.